ओके, मेरी आवाज आ रही है? आवाज आ रही है? हेलो, आवाज आ रही है?
यस सर।
यस सर।
ओके, तो कैमरा ऑन करो जल्दी से। आज ये वैसे पता नहीं क्यों कनेक्ट ही नहीं हो रहा था। सो यू ओपन योर कैमरास जल्दी से। आज कम ही आए हैं, 1 2 3 4 5 6 7 8 9 10 11। सभी कैमरा ऑन करो। तो आज हम इसको
से नेट बंद है इस वजह से।
अच्छा,
यस सर।
पुलवामा से कुछ गड़बड़ है?
यस सर।
ओके, अल्लाह रहम करे। चलो, वैसे आज हम इंशाल्लाह ये खत्म करेंगे। सो लेट मी स्टार्ट। एक्चुअली let me state Banach theorem, Banach-Stone theorem once more, क्योंकि लास्ट टाइम मैंने एक वर्ड भूल गया था लिखना, उसमें मैं लीनियर लिखना, तो बाद में मुझे ख्याल आया, तो डजंट मैटर, अभी इसको ठीक कर देते हैं। ओके, so let me state this theorem. Let X and Y be compact matrix, compact Hausdorff spaces. Let X and Y be compact Hausdorff spaces. Compact Hausdorff spaces. Compact में पता है that compact means every cover can be reduced to a finite subcover. Hausdorff means the distinct points can be separated by disjoint open sets. And इसको admit करते हैं. And let T be a subjective linear isometry. मैंने सब्जेक्ट मतलब लास्ट टाइम जब मैंने स्टेटमेंट देखी, फिर उस रिकॉर्डिंग में मैंने लीनियर नहीं लिखा था, बाकी सब कुछ ठीक था, लेकिन उससे तो फर्क पड़ेगा। Linear isometry from Cx, that is scalar valued continuous functions on this compact Hausdorff space, to Cy, that is the scalar valued continuous functions on Y, which are Banach spaces, of course. Then there exists an homeomorphism. There exists a homeomorphism tau from Y to X, means there exists a homeomorphism from X to Y, जैसा कि मैंने last time कहा था, and a function f belonging to Cy, नहीं h मैंने रखा था उसका नाम, h belonging to Cy means it is a scalar valued continuous function on Y, such that h of Y in mod is equal to 1 for all Y belonging to Y, and df applied to Y, the connection between this t and tau would be via this relation, h of Y multiplied by f of tau of Y. Let's call this star for all f belonging to Cx, of course, and of Y belonging to Y. Also the converse is true. Also the converse is true. यहाँ पे मैं लिखता हूँ इसको, कभी कभी हम ऐसे, अगर तुम सिमन्स देखोगे वो कहेगा Cx is isometrically isomorphic to cy if and only if, this would be a shorter form of this statement, if and only if x is homeomorphic to y, where x is compact Hausdorff. So ये भी एक इसका statement हो सकता है, but it does not tell you कि वो जो homeomorphism और जो isometry है उनमें आपस में क्या relation है. But you can get it via Banach plus. So वो भी एक approach है. तुम उसको पढ़ना चाहो तो सिमंस का जो आखिरी हिस्सा है उसे पढ़ सकते हो, जो उसने स्पेक्ट्रल थ्योरी दी है लास्ट में. सिमंस तुम्हारे पास होनी चाहिए. That's an excellent book for higher mathematics in general and functionalists in particular. Proof. अब क्योंकि मैं नए से ही शुरू कर रहा हूँ तो let me do also जो मैंने थोड़ा सा वहाँ किया था converse, वही मैं करूँगा जो मैंने वहाँ किया था. That's the simple one. We first show that, लेकिन चूंकि मैंने अब लीनियर ऐड कर दी, मतलब लीनियर लिखना मैं भूल गया था तो वो खराब हो जाता, क्योंकि इसको YouTube पे हम अपलोड भी करते हैं तो गलत स्टेटमेंट नहीं कर सकते. We first prove the converse. So let h and tau be as stated, and h is a continuous function on y, that's, and tau is a homeomorphism from y to x, and suppose let star hold, then t is indeed, then t is linear, जो मुझे अब लिखना है, क्योंकि t linear है. You take t of f1 plus f2, because जहाँ point wise addition होगा it would be f1 plus f2 at tau of y, so t is clearly linear. And since tau is a homeomorphism, since tau is a homomorphism, it implies that, and modulus of any h of y is never 0 because its modulus is 1 for all y belonging to y. Norm of t of f then would be, of course, by definition, supremum of y belongs to y, modulus of t of f applied to y, and if star is true, this should be equal to supremum y belongs to y, h of y into f of tau y. And this is modulus, so it would be just supremum y belongs to y, f of tau y. And since this is a homeomorphism for every y, there would be some x. So this would be basically supremum x belongs to x, f of x, which is equal to norm of f. So indeed, t is an isometry. T is a linear isometry. Basically, हमें अब सिर्फ on to दिखाना है to prove the converse. Now to show that t is onto, now t is a map from, remember, cx to cy. I have to show that corresponding to every something in cy there exists some cx which is related by star, which has the same relation to star define karta hai. So let g belong to c of y, or cy means continuous function on y, and define, हम इसकी दिखाएंगे, इसकी प्री इमेज है actually, f composition f is equal to 1 by h composition tau inverse multiplied by, यहाँ multiplication है, g of tau inverse. So then f belongs to cx because ये 0 नहीं है और बाकी सब कुछ continuous है, no issue. So composition of continuous functions continuous. एक ही जगह दिक्कत हो सकती है अगर h 0 हो, जो कि नहीं है, इसका डिनोमिनेटर किसी भी x के लिए 0 नहीं होगा, because h will not be 0 for any tau x which belongs to x, right? Any tau inverse of, जो भी मैंने tau की वजह tau inverse का, but that's understood. Okay, so then f belongs to Right. And TF of y मैं दिखाऊंगा is actually this ये जो मुझे g मिला था is equal to, by our formula, it should be hy multiplied by this applied 2 tau of y, and 1 by h composition tau inverse multiplied by g composition tau inverse applied to tau of y. And using the definition of pointwise multiplication of functions, so it would be 1 by h composition tau inverse of tau of y multiplied by g composition tau inverse of tau of y. As you can see, this is just h of y divided by h of y into g of y. That's equal to g of y. This is true for all y belonging to y, which implies what? D of f is equal to g. And I have been able, for each g there exists some pre-image inside, so which implies that and the converse is proved. अब जो मेन है हमारा थ्योरम प्रूव करना, उसमें हम जो पिछले 2-3 रिजल्ट्स किए हैं वो सारे आएंगे. To prove the theorem, now remember that, now I am given that t from cx to cy जो है is a linear surjective isometry, and it's basically a isometric isomorphism. You know, its isometry means 1 onto means bijection, and it preserves everything. It's linear isometry. It preserves the norm as well as the linear structure. So T is a isometric isomorphism. Now we know that T is an, yeah, it is given. And we know that T star is an isometric isomorphism. ये हम कर चुके हैं. Isomorphism if T is an isometric isomorphism. वही नहीं, हमें पता है इसका इनवर्स का रिलेशन भी क्या है. And T star का जो इनवर्स है वो बराबर है T inverse का स्टार. This we have done. Also ये भी हम कर चुके हैं. T star जो है is a weak star homeomorphism. And you have to remember that. So T star would be a map from cy star, dual of cy, to cx star. पता नहीं मैंने कुछ ज्यादा ही डाल दिए ब्रैकेट्स, इसलिए एक को डिलीट करते हैं कम से कम. Okay, T star is a map from this to this. You have to remember. Okay, so we are seeing that it's a weak star homeomorphisms. ये भी हम prove कर चुके हैं, such that it sends unit ball onto unit ball. यानी T star of the unit ball inside cy star. ये जो सब लिखते हैं हम, इसका मतलब unit ball होता है सारे ऐसे वेक्टर्स जिनका norm less than equal to 1 है. This we have done. So this we have done. So also now note that all closed balls are convex, and T star क्योंकि isometric isomorphism है, it's a linear bijection. अब linear bijection, चलो मैं लिखता हूँ एक होम असाइनमेंट, ये बिल्कुल इजी है दिखाना. If T from a convex set x to y is a linear bijection, then T sends extreme points. Of course ये तो convexity को भी preserve करेगी, तो ये extreme points को भी it would send extreme points to extreme points. Of course of convex sets. ये तो खुद कर सकते हैं. It would send convex sets to convex sets. That's obvious. Because ये linear preserve करता है तो. लेकिन इसमें bijection होना जरूरी है. जैसे every linear map need not send extreme points to extreme points because projection is a linear map. तो अगर मैं इसको project करता हूँ इस set को, तो it would be this whole set would be projected. अगर मैं देखूँ on x-axis, this would be the resulting set. और इसके extreme points ये हैं. और this point जो है जो इधर पहुँचा, वो extreme नहीं है. Although it was extreme in the domain. So if the map 1-1, चूँकि projection 1-to-1 नहीं होती, it's a many domain map. So तो ये bijection होना चाहिए. 1-1 या bijection होना चाहिए. तो it's a linear bijection. So it won't send. और चूँकि ये closed sets हैं, तो they are all, ये भी convex set है, ये भी convex set है. So T star is a linear bijection from which sends C P C Y star on to, ये हम कर चुके हैं, P C X star. So इसका मतलब T, it would send extreme points to extreme points. And the T of epsilon जो extreme points of B C Y star जो होगा, it would be the same as extreme points of B, ये हमारा X star. लेकिन हमें पता है, but चलो मैं लिख देता हूँ. Now since CX star जो Rees representation theorem है, जो हमने प्रूव नहीं किया लेकिन हम यूज किया, हम यूज करेंगे, is isometrically isomorphic to the complex valued Borel measures on X. Therefore, I can say T star of extreme points of BMX, or MY, sorry, MY, is equal to extreme points of BMX. Now we know that तुम्हें पता हो, हम कर चुके हैं, extreme points of unit ball of MX are just alpha times del X type के, where modulus of alpha is equal to 1 and X belongs to X, where this is our Minkowski measure कह लो या Dirac measure कहते हैं शायद इसको. This is equal to 0 if ये तो मैं कर ही चुका. 1 is equal to 0 otherwise. So इसका मतलब क्या हुआ? अगर this is mapped to this, so let y belong to y. अगर y में है, then there exists a unique tau y. अभी मतलब something that depends upon y, जिसको नाम मैंने दिया tau of y, belonging to x, such that, and a unique scalar, जिसको मैं नाम दूंगा h of y, belonging to k, such that modulus of h of y is equal to 1, and t star of del sub y is equal to hy into delta tau of y. मेरे कहने का मतलब है, अब चूंकि इसके जो मतलब इसके अंदर एक है del y एलिमेंट है ना, for every y belonging to y, del y belongs to bmx. मतलब इस यहाँ पे यानी वो जो del y है, यानी tau of that del y should be inside this, लेकिन इसके एलिमेंट से of the type alpha del x. now चूंकि जब मैंने ये y चूज किया, मुझे यहाँ क्या बोलते हैं, कोई चीज मिली है ना. so चूंकि मैंने पहले y की चॉइस की, तो ये जो अल्फा है, this would also depend upon y and this x would also depend upon y. तो इसका नाम मैंने दिया h of y और इसका नाम मैंने दिया tau of y, यानी यहाँ जो x है. so because they are dependent upon my choice of y, and of course because this is a 1-1 map, so it would be a unique one, right? In fact, it's a function. It would be a unique one. For something here, you would find some unique here. दो तो नहीं मिल सकते एक के साथ, because it's a well-defined function. हाँ, ये जो alpha है जिसका नाम मैंने h of y दिया, which depends upon my choice of y, उसका मॉडुलस 1 होना चाहिए, बिकॉज इसके जितने भी मेजर्स हैं वो इस टाइप के हैं, जितने भी इसके एलिमेंट्स हैं वो इस टाइप के हैं. By the uniqueness I can say h is a map from y to k and tau is a map from y to x are well defined. And I have been able to define these maps, right, which are related with by t star with this relation. Keep that in mind. Now I have to show that indeed this tau is a homeomorphism and h is a continuous and our relation star holds. जो ना हमने originally कहा है कि हम prove करेंगे. So keep that in mind. So now I have two maps to prove first that h is continuous and tau is a homeomorphism. Claim 1. H, which is a map from y to k, which is continuous. Now let y belong to y, जो कि हम net में, we would prove it by via the nets, and y alpha, where alpha belongs to some index at delta, be a net in y such that y alpha converges to y. Okay. Now since जो हम अभी हम कर चुके थे f from x to cx star under weak star topology defined by, वैसे ये मुझे लिखना नहीं चाहिए था, defined by f of x is equal to del x. ये हम कर चुके हैं. ये मैप हमने दिखाया is a 1-1 homeomorphism basically. मतलब it's a homeomorphism onto the image fx. चलो मैं ऐसे लिख ही देता हूँ. तो अगर ये homeomorphism है तो continuous है in particular, of course under weak star topology, ठीक है ना. तो उसका मतलब क्या हुआ? उसका मतलब ये हुआ कि अगर y alpha converge करेगी to y को, तो अगर यहाँ पे कोई चीज converge करती है मतलब x में, मतलब x की जगह y मान लो, तो चलो मैं y ही लिख देता हूँ, कहीं तो डर में, चलो y लिख देते हैं. हालांकि y is just a compact first of space. चलो ठीक है, चलो यहाँ y लिख देते हैं, क्योंकि मैंने स्टेटमेंट वहां जो मैंने x लिया था ना, वहां जो एक्चुअल हमने थ्योरम प्रूव किया. Now this is a homeomorphism onto the image. It implies that del y alpha would converge under weak star topology to del y. Of course, this is all happening in cy star. They are functionals in y. Okay. Okay. Also, now since T star is weak star continuous, it implies that we have limit over alpha, h alpha, I should write h of y alpha, h of y alpha, okay, tau t y alpha, delta tau y alpha is equal to limit by definition. इसको हमने define किया है. Limit over alpha, this thing is the same thing as t star of del y alpha, और ये del y alpha weak star topology में यहाँ जा रहा है और ये weak star continuous है. This should be t star of del y, but that would be by definition h of y into delta tau y, delta sub tau y. So what does that mean? Now this is true, right? Now we know that if I define a map by this capital 1 from x to k by 1 of x is equal to 1, no, which is a constant map, everywhere 1, is clearly, मैं लिख देता हूँ for all x, यानी वो मैप जो हर चीज को 1 पे मैप करता है, for all x belonging to x, then 1 belongs to this cx, it's a continuous map on x, and I can write limit alpha h of y alpha is equal to limit over alpha h of y alpha multiplied by del y sub alpha of 1 of this functional. You know that del y of f is equal to f of y for all f belonging to what's that c, जहां पर भी हम हो cx है, cy है, whatever, ठीक है. So I'm inside y, so let's make it y. Yes, y's are in y, so यहाँ y लिख देते हैं, y. So h alpha h, so this would be limit alpha h y alpha into del y alpha would go under this. Okay, this is limit h alpha, so this is this thing, और हम प्रूव कर चुके हैं ये इसके बराबर है. We know this limit is equal to h of y into 1. यहाँ सीधे लिख देते हैं, पहले लिमिट लेते हैं, फिर उसका वैल्यू तो 1 है. So this is because this is a constant function 1. So this would be del y of 1, that's equal to h of y. And since y is arbitrary, it preserves the convergence of nets, implies that this tau is, this h is continuous. अब थोड़ा दूसरा लंबा चौड़ा है हमारा claim 2, जो हमें दिखाना है, वो tau is a homeomorphism, जो ना हमने इस फॉर्मूला की मदद से डिफाइन किया, homeomorphism. Again, and you have to remember that tau is a map from y to x, where both of these are Hausdorff compact spaces. Okay, so tau is a homeomorphism. So let, of course, tau is a map. So let y belong to y, and of course y alpha be a net. Alpha belongs to some index set, a partially ordered set. Be a net in y such that y alpha जो है, this converges to y. I have to show that no, tau of y alpha converges to tau of y. To show that tau is continuous, फिर आगे चल के हम देखेंगे. Now limit alpha del tau at y alpha would be equal to, let me write it like this, limit alpha, मैं इसको लिखूंगा h y alpha, क्योंकि मुझे पता है इसका it's not 0, इसका इनवर्स लेता हूँ, यानी 1 by this number, तो मैं गलत लिख रहा हूँ, तो इसलिए it is y sub alpha, ये y sub alpha multiplied by h at y alpha, y sub alpha into del tau y alpha. So मैंने simply multiply किया number by its inverse, so we know that. Now since scalar multiplication is continuous, this would converge. We know that this is continuous, so this would be just h of y, right? And this thing, we know where does this converge. We already have shown that h y alpha जो है, to prove that h, this is continuous, हम ये इससे पहले वाली इक्वेशन में ये हम दिखा चुके हैं, this actually converges to hy tau del y. Sorry, h tau y. H tau y. Sorry. So this is actually h inverse into hy into delta y. अब मुझे पता नहीं मैं अगर पीछे जाऊं उस इक्वेशन का नाम दूं. Yes, this one. Let's call this one. Let's call this Roman 1 by 1, which is equal to delta y. Now again, वो जो f map था. So which implies that since yeah, it implies that simply tau y alpha converges to tau y. Why? Because जो वो map था ना f from y to what was that? C y star and weak star topology. Right. Given by f of y is equal to del y is a homeomorphism. So if this doubt range में convergence है net की तो domain में भी होगी. So that's the idea. So hence tau is and since y is arbitrary, tau is continuous. पहला वाला हिस्सा हो गया. इसके बाद suppose that y1, y2 are two distinct elements of y with, and that means y1 is not equal to y2. And since जो अभी हम discuss करते रहे हैं f is 1 1 because it's a homeomorphism वो हम कर चुके हैं. यानी f मेरा मतलब है वही मैप जो हम अभी तक डिस्कस कर रहे थे. तो it implies that del y1 cannot be equal to del y2, which implies that hy1 bar and a complex conjugate into del y1 is not equal to hy2 bar del y2. अब ऐसा क्यों होगा? Because otherwise हमें क्या मिलेगा? We will get modulus अगर ये दोनों बराबर हुए, so that would give us del y1 in mod is equal to del y2, right? Where y1 is not equal to y2. मैं क्या लिख रहा हूँ? तो अगर otherwise चलो पहले लिख देता हूँ. hy1 का बार अगर ये दोनों बराबर हो गए तो इनका मॉडुलस बराबर होगा. It's something like this. I should actually अगर ये दोनों बराबर हुए तो they are basically maps. तो मेरे कहने का मतलब है then I will get hy1 bar del y1 at f is equal to hy2 bar del y2 at f for all f belonging to cy. मतलब ऐसा होगा. तो अगर ये दोनों बराबर है तो इनका मॉडुलस भी बराबर होगा because these are complex numbers. अब चूंकि इसका मॉडुलस 1 है given, तो इसका मतलब होगा mod ये del y1 of f is equal to del y2 of f for all f belonging to continuous functions over y. So which would imply by definition f of y1 is equal to f of mod of f of y2 for all f belonging to cy, sorry, but y is compact Hausdorff and therefore normal, and hence normal. There exists a function f belonging to cy such that f of y1 जो है वो 0 है and f of y2 जो है वो 1 है. तो ऐसा तो हो ही नहीं सकता for all f के लिए ये मॉडुलस बराबर. यहाँ तो एक 0 आएगा एक 1 आएगा. So I can assume that they cannot be equal. है ना ये जो बार है. Once I am done, I move to the last leg. And since T star is 1 1, T star is 1 to 1 and you have to remember ये जो सभी हमारा ये फॉर्मूला है अभी तक वो ये है कि del star of T star of del sub y is equal to h of y del tau y. ये सारा हमारा tau और h इससे defined है इस relation से. लेकिन ये T star is an isometric isomorphism because T is an isometric isomorphism, so it is 1 to 1. अगर ये 1 to 1 है तो उसका मतलब ये हुआ कि अगर मैं ऐसे लिखूं del tau y1 वो by this formula इसको मैं लिख सकता हूँ h y1 का bar into h y1 because ये 1 है, it is conjugate into this complex number, so it will be mod of h y1 square, that's 1 del tau y1 at y1, so that would be equal to T star of h y1 का bar into del y1 by this formula because this is the formula and T star is linear, तो scalar बाहर आएगा और this is a vector, this is a scalar बाहर, then apply this formula, so this is equal to this. लेकिन ये इसके बराबर नहीं है तो इनका image भी बराबर नहीं होगा क्योंकि ये T star is 1 1, so it would not be equal to T star h y2 bar del y2, right? क्योंकि T star is 1 to 1, which is nothing but going reverse direction में अगर हम जाएंगे del tau y2. So which implies that अब चूंकि ये जो f है वो 1 1 है, ठीक है ना? अब चूंकि f is 1 1 जो ना अभी तक हम डिस्कस करते हैं f कौन सा मैप है, कैपिटल है, तो it implies that tau y1 cannot be equal to tau y2 because tau is 1 1. अगर डोमेन में डिफरेंट एलिमेंट्स है तो रेंज में भी डिफरेंट ही होंगे. So f ना वो जो हमने इससे पहले बहुत बार यूज किया, hence tau is 1 to 1. तो 1 to 1 हमारा हो गया. अब जरा on पे आते हैं. Now let x belong to x. Since T star is surjective, remember that T star is an isometric isomorphism, so in particular surjective. Right. So we can we conclude there exists mu belonging to the set of extreme points of B and Y, that means our domain, such that T star of mu is equal to del x. Because for every x there is a del x which is an extreme point here. मेरे कहने का मतलब है I know that T of extreme points of B, Y is contained, T star is equal to, oh sorry मैं गलत लिख रहा हूँ, ये सब में okay, this is B and Y, this is extreme points of B sub mx. Okay, so इस तरह से है, तो अगर यहाँ पे कोई एलिमेंट है जो कि है del x, तो उसका एक प्री इमेज होगा यहाँ पे, right? So I must have T of T star mu equal to del x. Moreover, furthermore, for some beta belonging, ये अभी खत्म होने वाला है, तो so let me cut it here, तुम फिर से ज्वाइन करो. In case तुम मैं इसे बंद कर रहा हूँ तो तुम फिर से